All right, ladies and gentlemen, let's get into this test review here. This is something that I promised I would do for you, and I want to make sure that you know we're going to be using the air quotes here, how to cheat method to do this test review. And again, the purpose here is to make sure that you know that there is a solution and you can work towards that in your own side work. This is a method that is going to help you with your homework and just in general. It's going to make you more independent about math work, so you're not stuck being unable to solve the problem. And so if we look here at question 1, we have to solve each system by graphing. So it would help to know where we're headed, right? What is it that we're looking for? So the first thing I'm going to do is go to Mathway, or Desmos test mode would do just fine, and type in 2x minus 3y, or minus y, equals 1. And then I'll type in 2x plus y equals 3. Okay, I can see that the intersection point is at 1, 1. So I know that it has a solution and that it's 1, 1. All right, let's go back to our page here and see that 1, 1 is in fact a solution. So I'm not going to circle it yet because I haven't earned the right to circle it just yet. I have to do it now. All right, what else did I notice about that, about those lines when we looked at the graph? Let's go back to that real quick. I see that it's graphed in quadrant 1, and I've got one line that's going down, that's a negative slope, and I've got another line going up with a positive slope. Okay, so we're also noticing here that that downward sloping line has a y-intercept at 3, and the upward sloping line has a y-intercept at -1. So this is my goal. All right, think of it as a goal and not as, ooh, I got the answer, let me just scribble it down and see if he doesn't check the side work. Let's not do that. Let's try to teach ourselves here, because it's not about the grade. It's about knowing how to do it. Okay, so let's now figure out what we have to do to achieve what we just saw in Desmos. Let's go down here and rewrite one of those equations. 2x minus y equals 1. Now, when we're solving systems by graphing, we have to solve each equation, and I'll move my hand here in a second. I can't help being left-handed. We have to solve each equation for y in slope-intercept form. Okay, so what is slope-intercept form? That's y equals mx plus b. Okay, so that's what we actually need to show. So let's go down here to that first equation in the system and solve it for y. The first thing I need to do is subtract 2x from both sides. Those 2x's cancel. And now I'm left with negative y equals, and remember we want it to look like this, y equals something x plus something, or minus something. So I want to put the x term up front, just like this. You don't combine these two. And now it would help to remember that in front of the y variable, there is a -1. Okay, so it's not just a negative symbol, it's a -1. And I wish that math just wrote that 1 all the time, but they don't. And now to get rid of it, because it's -1 times y, I have to divide each term in my equation by -1. So those two -1s cancel out because anything divided by itself is 1. And so I have y equals -2x over -1. And then I have plus 1 over -1. And now we just have to work with this. So remember what our goal is. Our goal is to get the equation in the form y equals mx plus b. So I need to get this -2 and this -1 to sit out to the left, and I need to have this x all by itself. All right, this seems to be a key sticking point for students. So let's set y equals and just examine what we're about to do. Up here on the top, I have -2 times x. Okay? So I have a fraction here, -2 times x over 1, or over -1. Now I don't know where the ball was dropped, okay, but somewhere in your education, you should have been taught that you can rewrite this thing up here as two separate things. We can write the -2 over the -1, and then this is multiplied, okay, by x. In other words, you can move the terms around a little bit. And then you can simplify that fraction, -2 over -1, as 2 over 1, because the negatives cancel out. And if you wanted to, you could further simplify that fraction down to a whole number where you just write 2x. So we're going to use this final form here, 2x, y equals 2x. And now I have to do the analysis over here. I have 1 over -1. Again, I'm very curious where the learning gap occurred. But you have to know that 1 divided by -1 is -1. And this is one of those foundational things where if it's not something that you know, it's something that we've got to learn very, very quickly, or the math will get away from you and you won't understand what's going on. All right, that's my big concern. So once you get the equation in this form, y equals 2x minus 1, you can identify the slope, m, as 2, and you can identify the y-intercept, b, as -1. Those two things are important. So for this equation, the slope m equals 2, and the y-intercept equals -1. Now you can't just rush out and graph that. You need to understand the slope always as a fraction. So write 2 as a fraction, 2 over 1. The top part here, this is the rise. And the bottom part here, this is the run. Okay? So when I go back to my graph, what I'm going to do is find -1 on the y-axis, and I'll put a dot there. So let's go back to the graph and find -1 on the y-axis, and we'll put a dot right there. That's the y-intercept of this top equation. And now we're going to use the rise over the run form of our slope to find the next point on the line. So I will start at the y-intercept and then go up 1, up 2, over 1 to the right, and I'll put a dot there. And I can find more points by going up 1, up 2, 1 to the right, put a dot there. Up 1, up 2, 1 to the right, put a dot there. I can do the same thing in reverse. I can go back to this point that I just drew and go down 2 and 1 to the left, and I'm still back on my line. And then down 2 and 1 to the left and be back on my line, down 2, 1 to the left, and I can keep going. Down 2, 1 to the left, down 2, 1 to the left. So those are all the points that we can plot using the slope. And we'll connect all those dots by taking a straight edge. This is why a straight edge is so important. Okay, because precision is crucial when you're trying to do work with a line. It's got to be precise. Okay, so we graphed in one of our lines. And if we look back at Desmos, that's this green line. That's what we just plotted in. We had a y-intercept at -1, and we went up 1, up 2, over 1. See? And there we are at 1, 1. And then we went up 1, up 2, over 1. And here we were over here at this point, 2, 3. Okay? So that's what we were doing when we were plotting in that line. So this green line right here is identical to this red dotted black line here that I just drew in. Now let's see if we can do the same little magic trick with 2x plus y equals 3. Let's take 2x plus y equals 3, and let's solve for y and get that equation in slope-intercept form. So first I'll subtract 2x from both sides. And on the left, I'll do it this way this time. 2x minus 2x is 0. Okay, that's why I take that shortcut and just draw a line through it. Because it's 0, it's irrelevant, it's gone. It's been moved over to the right side of the equation. The reason I chose to subtract is because hiding in front of the 2 is a plus sign. It's positive 2x. So that's why I chose to subtract. If it had said negative 2x right there, I would have added. And that's what's driving that decision. If it's positive, I subtract. If it's negative, I add. I'm going to do the opposite thing. So now I have y equals, and then here we want to put this negative 2x term up front. Okay, negative 2x. And then we want to put this 3. Now, again, this has been a point of confusion. How is it that I'm coming up with that plus sign? Well, it's a positive 3. So that's how I'm coming up with this plus sign right here. Plus 3. I'm actually just moving these terms around. And I just want to point something out. I could have just as easily written y equals positive 3 minus 2x. Okay, those are equivalent. So is this. Y equals 3 plus negative 2x. Okay? So there's no such thing as subtraction. There's just the addition of negative numbers, if you want to think about it like that. But I don't want this form. Okay, this form doesn't do anything for me. And this form doesn't do anything for me. Because remember, I'm actually seeking a form, right? I'm trying to mimic this form, y equals mx plus b. So this is the form that I want, y equals negative 2x plus 3. So let's analyze that a little bit. I have y equals negative 2x plus 3. All right, what's my slope? Well, we can play a game of match. I want my equation to be in y equals mx plus b form. So I can match the letters with the numbers. This m goes with this negative 2. And this b goes with this positive 3. All right? So let's write m equals negative 2 and b equals 3. Now this b is the y-intercept. So 3 is the y-intercept. Okay, and this negative 2, this is the slope. But writing a slope of negative 2 isn't very useful to us because there's no rise and run. You need two numbers there. So we just notice that negative 2 equals negative 2 over 1. I can always write a whole number, whether it's positive or negative, I can always write it over 1. And that's going to be useful for us because I now can see the rise, or in this case, the fall, of negative 2, and I can see the run of 1. So here's the game plan. We're going to go back to the graph, and we're going to start by plotting 3 on the y-axis. So the coordinates of your y-intercept will be 0, 3. Okay? And that should be setting off an alarm bell in your head, because back on Desmos, you saw that the y-intercept was 0, 3 for this downward sloping line. Okay? Now, remember also we said it was downward sloping, so it had to have a negative slope. And lo and behold, the slope is negative 2. So we do have a downward sloping line. You see, I'm trying to help you find the connection between the picture and the equation. All that information is packed into this equation, y equals negative 2x plus 3. So let's now go back to our graph, and let's copy over our information here. So I've got a slope, or I've got a y-intercept rather, that starts at 0, 3, right here. Okay? And then I've got a slope that says go down 2 from any point on your line and then go over 1 to the right. So I'll start that. I'll start at the y-intercept and go down 1, down 2, and then over 1 to the right. And you see, I've already mapped over my solution right there. I know what the solution is. But I can keep drawing line by going down 1, down 2, over 1 to the right. Down 1, down 2, 1 to the right. Down 1, down 2, 1 to the right. I can go backwards. I can go up 1, up 2, 1 to the left. So once I get all those points plotted in, I'm ready to bring over my straight edge and draw in a line that passes through all those points. It's getting caught up. That was getting caught up on the edge of my paper. So let me bring this in and draw a line that passes through all those points. just like that. This downward sloping line right here is this blue, okay, this bottom equation, 2x plus y equals 3, which we turned into y equals negative 2x plus 3. This top equation is this red one, 2x minus y equals 1. But we turn that into y equals 2x minus 1. And now we identify where these lines intersect. Okay, so these lines intersect right here at this point. So what are the coordinates of this point? Well, 1, 1. The x is 1 and the y is 1. So x equals 1 and y equals 1. So when you go to your answer choices, you see that it's not infinite. It's not 1, negative 4. The lines don't intersect at negative 2, 1. The place where the lines intersect is at 1, 1. And it's only at this point, when you've done all this work, that you can feel comfortable circling D. Okay? So on number 2, we can move much, much faster, and we'll try to move briskly through the rest of it, because otherwise this video would be, 10 hours long. And as you know, I'm perfectly capable of recording a 10-hour video, but I don't think anyone would watch it. Okay, so now we'll work on number 2. This is going to be my side work, but let's take a look at number 2. The system we're given is x plus y equals negative 1, and x minus 2y equals negative 4. Well, let's see. What do those lines look like? Where do they intersect? X plus y equals negative 1. Okay, so I've got a y-intercept there at 0, negative 1. That's pretty cool. Let's see if these lines cross. X minus 2y equals negative 4. Okay, so over here, I see that they cross at negative 2, 1, and that red line, that second equation, has an upward slope. The first equation had a downward slope. Okay, so these are my key points. My black line, my top equation, has a y-intercept at negative 1 and slopes downward. And my bottom equation has an upward slope and it crosses at 0, 2. It has a y-intercept of 2. So these are the things I'm looking for as I go through my solution process. So let's go through that solution process together. Okay, we see the answer, but that's not what we're here to do. We're here to actually solve problems. All right? So let's see if we can fit this all on this page without being cramped. First, we have to take the first equation, x plus y equals negative 1, and we have to solve for y. Now, how do you know what to do? Let's put in some information. We know that x is positive x because there's no negative sign, and we know that there's a 1 hiding in front of that x, and there's also a 1 hiding in front of that y. So that's all the hidden information. Maybe this helps make it easier for you to see what we should do first. I want y to stay by itself on the left side of the equation, so I don't want to touch y. So I want to get rid of this plus 1x. So to get rid of it, I would subtract 1x from both sides. This is the same thing as subtracting x from both sides. It's the same thing. Well, positive 1x and negative 1x cancel each other out. It's 0. So it zeroes out, or it goes away. The 1x moved over to the right side of the equation. So now I'm going to write y equals. I don't have to write that 1 in front of that y. If it was negative, it might be helpful, but I don't have to write it in this case. And now I'm just going to carefully relocate the information. See, I've already got this. This is the slope piece. Okay? And this is the y-int piece. But I want the slope piece to come first, and then the y-int piece. So this part here, this is mx. And this part up here, this is b. So I want the mx to come first, so I'll put negative 1x, and then I'll bring this negative 1 down and put it afterwards. And now I hope you understand why this is now in the form y equals mx plus b. So what's m? Well, m is negative 1. It's easy to see in that, isn't it? And b is also negative 1. Okay, so let's take this slope piece, m. m equals negative 1. Well, negative 1 is also equal to negative 1 over 1. And the reason we want to write it that way is because now I see my fall and I see my run. So I fall 1 and run 1. My b value, my y-intercept value, is negative 1. This means that the y-intercept is located at 0, negative 1. So I can go plot that coordinate and then use that point and fall 1 and run 1. So let's go up to our line and let's plot that coordinate at negative 1. This is going to be the top equation. I'll plot that coordinate at negative 1. And then I'll go down 1. Okay, fall 1, run 1. Down 1, over 1. Down 1, over 1. Down 1, over 1. Okay? I can also go the other direction. Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And there's all the points on the line. Okay, so you bring in your straight edge now, and it's time to put the line down. Okay, there's that line. So we have a downward sloping line, and this is the x plus y equals negative 1 line. All right, it crosses the y-axis at 0, negative 1. Did we do it right? Let's go check. Let me hide this piece for a second. I've got a downward sloping line that crosses the y-axis at 0, negative 1. Okay? And, you know, if you wanted to look at that slope piece, you could do that as well. From this point, we can go down 1, over 1, and we're back on the line. Down 1, over 1, down 1, over 1. So fall, run, fall, run. Here we can do the same thing. We can go up 1, over 1 to the left. Up 1, over 1 to the left. We always end up back on our line. That's how the slope works. Okay, So now we need to do the second equation. X minus 2y equals negative 4. So what are we hoping we find with that one? Let me hide that first equation and show the second one. I'm hoping that I get a positively sloped line, so m has to be positive, and I'm hoping that the b value is 2. Okay, so I'm hoping for a b value of 2 and an m value that's positive. And if you're clever, you can actually work out what the slope is visually. You start here at 2, and then you go up 1, that's rise 1, run 1, 2, and now I'm back on the line. So the numerator of the m value of the slope is positive 1, rise 1, and the denominator, the run part, is 2. So you have 1 over 2. So the slope is 1/2. Okay, so we're hoping for a 1 over 2 slope and a y-int at 2. So my equation should be y equals 1/2 x plus 2. And you can almost just read it from the picture. In fact, you can read it from the picture. Let's go back and see if that is in fact what the math shows. So x minus 2y equals negative 4. X minus 2y equals negative 4. And the question is this the same thing as y equals 1/2 x, what was it? I don't want to do it wrong. 1/2 x plus 2. Okay, is it the same thing as 1/2 x plus 2? All right, there's only one way to find out. First, let's notice that x is positive on the left side, and there's a 1 hiding in front of it. And I need to get rid of this positive 1x in order to further isolate y. So I'm working in reverse. So first I'll subtract 1x from both sides. Positive 1x minus 1x, you combine those two together, they equal 0. So we can get rid of them. And now I have negative 2y. And here I want to bring in this negative 1x up front. And put this negative 4 at the end. Okay, well, I'm not there yet. I still have to divide everything by negative 2 because there is a little invisible multiplication sign between negative 2 and y. So to uncouple the negative 2 from the y, I have to do the opposite of multiplication, which is division. So I'll divide every term by negative 2. On the left, these negative 2's cancel out because negative 2 divided by negative 2 is 1. And I now have y equals, and see, here's where we have to start pulling that fraction out in front. So we're not going to write negative 1x over negative 2. First of all, we have a negative over a negative, so it's going to become a positive. I just need to pull the numbers out front and put the x off to the right. So pull the numbers out front. You got 1 over 2. Then put the x off to the right of that. 1 over 2x. And now negative 4 over negative 2, we know that's going to be positive. Negative over a negative is a positive. I can write plus. And 4 over 2 can simplify down. 4 divided by 2 is just 2. So I can write 2. And look, they match. Y equals 1/2 x plus 2. Y equals 1/2 x plus 2. So this is correct. x minus 2y equals negative 4 is the same equation as y equals 1/2 x plus 2. The reason we want to write it like this instead of the way it was given to us is because now we can see the slope and we can see the y-intercept. We can read it. Right? So we can circle the slope and we can circle that y-intercept. So my slope m equals 1 over 2. And it's already written in a fraction form, so I don't have to worry about it. My rise is 1. And my run is 2. And then I have plus 2, so b, the y-intercept, is 2. And that means it crosses the y-axis at the coordinates 0, 2. So let's go up to our graph and let's plot all that. Let's go up to the graph and let's find 2 on the y-axis, 0, 2. So I start at the origin and go up 2 and plot this point here. And then starting at that point, I'll use rise over run. So my rise was 1 and my run was 2. I can plot in points. Okay, I can also go in reverse, down 1 over 2 to the left, down 1 over 2 to the left, just like that. And I can connect those lines, or those dots with a line, just like this. Okay, now does that look like the picture that we saw when we put it in Desmos? Let's turn on both equations. Yep. And they cross here in the Desmos at negative 2, 1. Where do they cross on our graph? Negative 2, 1. All right, so the place where they intersect is at negative 2, 1, x, y. And that's the solution to the system. X is negative 2 and y is 1. So let's go down and look at our answer choices. There it is, D, negative 2, 1. Okay, so only at that point, after all that work that we just did, okay, this work right here, I'll show you all the work in one frame. There it is, this work right here. This work right here is what we had to do in order to feel like we were justified in circling that letter D, even though we started by knowing this piece of information. We had to prove it. And I want you to understand something. Math class is not about getting the right answer. That's not what this subject is. Okay? This is where I should have been pointing. This is the least important part of this entire process. What we're trying to teach you in algebra is this. Okay? There's so much mental activity down here. It's like solving a puzzle. And this is the thing. So I want you to focus less on this. This is why a lot of math teachers do not allow multiple choice in their classroom, because they don't want you to focus on the answer. They want you to focus on the journey to the answer. This is what I'm trying to teach you how to do. I'm trying to teach you how to write this stuff like this and understand it, and then take it to a picture like this. Okay? That's what I'm really trying to teach you. I am not trying to teach you that the answer to number 2 is D. And that's kind of what the point is of this whole how to cheat thing, is that I want to get that out of the way right up front and show you the answer so you kind of get it out of your head. Like, well, he already showed me the answer, so what are we doing here? Well, that's not the point. Okay, the point is the journey, not the ending. Think about it when you watch a movie. Is the point of watching the movie to watch the end credits? No. Because if that was the point, every time you bought a movie, every time you saw a DVD or you watched a video, you would just scroll to the end of it and say, oh, I'm at the end of it. That's like picking up a book and saying, oh, well, there's this idiot over here, this nerd with glasses on, sitting here. He's been sitting here reading this book, page by page, line by line, word by word, syllable by syllable, and all this guy had to do was flip to the very end. Look, it says the end. I'm at the end of the book. Well, obviously, you would have missed the whole thing. That's like walking into the movie at the end credits and claiming that you'd been there the whole time. That doesn't make any sense. All right? So in this case, the journey is the point. All right? The whole point of this is the journey. Okay, so that was number 1 and 2. Let's look at number 3. We're told to solve each system by substitution. So again, now, let's get it in our heads. We're not here to find A, B, C, or D. And I'm going to prove that to you by showing you how to find which one it is. You go to Desmos, and you type in y equals 5, and negative 6x minus 2y equals negative 4. Zoom out. Okay, there it is. Right there. There's your answer. Okay, there it is. So I guess if that was the whole point, then we're done. We could just speed through the rest of them and be done in like 5 seconds. Obviously, that is not important. Okay, that's not the point. So if you were here to find out that number 3 is letter A, I want you to know that you've earned no credit. All right, we are not interested in people who just want to find out that 3 is letter A. Okay, those of us who care have to earn the right to circle that letter A. And we're going to earn it by taking the journey. So now begins the math class. That stuff in Desmos, that wasn't the math class. That was just the cheat. So I'm showing you how to cheat, and I'm telling you that it's irrelevant. Okay? There's your answer. You know, I'd almost be interested in seeing how many people actually believe that that's fine, that that's acceptable, that, okay, it's A, done, move on. That's just, that's not what we're doing. And that's why I hate the whole grading process, because we put this on you that if you don't get A, you fail. All right? But that's just horrible. That's a whole nother diatribe. Well, let's do this. So the first equation is already solved for y. There's nothing we have to do. It's good to go. Okay? So in substitution, the very first thing we need to do is solve one equation for one variable. Okay, did we do that? Yes. The first equation is already solved for y. So that was step 1, done. Okay, step 2 is to plug what y equals into the other equation. Okay, so that's step 2. So what that means is y equals 5. So I'm going to take that 5 and I'm going to place it down here and substitute it for that y. All right, plug it in. Plug it in, plug it in. So let's take that negative 6x minus 2, And then to plug it in, we have to do open parentheses 5, close parentheses, equals -4. All right, so what now, right? Well, now what we're trying to do is solve for x. This, I guess, is step 3. Solve for x. So let's get x by itself. First, we'll leave -6x alone. We're not ready to deal with him yet. We have to deal with this -2 times 5. Well, -2 times 5 is -10. So I'll simplify that by writing -10, and then bring down the equal sign and set that equal to -4. Okay, so again, we can't touch the x until we get rid of the -6. And we can't get rid of the -6 until we get rid of the -10. So you have to work in reverse, right? Think about it this way. You can't get to the pit of an apple until you eat all the way around it. Okay, so this is the pit of the apple. Okay, this is the skin. So we've got to take the skin off the apple, and then here's the stuff all inside, the part that you like to eat. All right, we got to get rid of that, and only then will we see the core. So first, let's get rid of the apple peel by adding 10 to both sides. All right, so -10 plus 10, those cancel out because -10 plus 10 is 0. And I just bring this guy down here, -6x equals, okay, and now we have to combine -4 and +10. Well, that's basically 10 minus 4, which is 6. Okay, so now I'm at the part where I've gotten rid of the apple peel, or let's talk about an orange. Well, there's no core to an orange. That doesn't make any sense. So we'll stick with the apple. I've gotten rid of the apple peel. Okay, the 10's gone. And now I've got to get rid of the stuff around the core, the white part of the apple. Okay, well, right now, it's holding on to the core with multiplication. So to fight multiplication, I have to use its nemesis, which is division. So I have to divide both sides by -6. Okay, -6 divided by -6, those cancel out because that's just 1. And now I'm left with x equals 6 divided by -6. Let's see, what's 6? 6 over 6 reduces down to 1, and then I have this negative here. So it's -1. X is -1. All right, so now we did number 2 and we did number 3. Now what's step 4? Step 4 is to plug x back into an equation. It can be either one, into either equation. And solve for y. Okay, so here I've run out of room on my paper, so I'll bring in the scratch paper. We have to find an equation that contains x. All right, so you can't plug it into the top equation. We can only plug it into the bottom equation. And we saw that x is -1, so I'll write -6, open parentheses, -1, close parentheses, minus 2y equals -4. Okay, so now I want to solve for y. But now I've got to do this in pieces, right? First, I've got to remove the apple skin by getting rid of this nonsense right here. But I can't even get to the apple skin because there's a wrapper around the apple. Okay, I've got to multiply here -6 times -1. Well, a negative by a negative is a positive, so -6 times -1 is just +6. So let's bring down this -2y here. We can only do one step at a time. Okay, now we're back to where we kind of feel comfortable because this is the apple skin. Okay, here's the stuff in the middle, and there's the core. All right, so this is +6. So I have to get rid of it by using its arch nemesis. Okay, positive's arch nemesis is negative. Okay, so +6 -6. That's what will get rid of that 6, a -6. And I have to do that on both sides. Okay. Here on the left side, they cancel each other out. And I've got -2y equals, and now I'm basically adding two numbers that are negative. So my answer is going to be negative, and 4 plus 6 is 10. So -4 plus -6, or -4 minus 6, is -10. All right, now we're at the moment where we can get to the core of the apple, and we just have to find the nemesis of multiplication to do it. Okay? Well, the nemesis is division. So we're going to go in here and divide everything by -2. On the left, the -2's cancel, and I have y by itself equal to 10 divided by 2. Negative divided by a negative is a positive. So I just do 10 divided by 2. Or I reduce 10 and 2, right? What I'm actually doing is I'm dividing the top and the bottom by the greatest common factor of 10 and 2, which is 2. So 10 divided by 2 is 5, and 2 divided by 2 is 1. So it's just 5 over 1, or 5. So y equals 5. X equals -1. And y equals +5. So when I want to write that as a solution to a system, I have to write it as a coordinate pair, x comma y. So I write -1, comma 5. Okay? Does that match what we found in Desmos? Yes, it does. There it is, -1, comma 5. I think it's quite magical that we can actually find what that computer can do. Okay? And so at this point, and only at this point, are we legally, okay, kind of like legally able to circle A as our answer choice, because we finally put in the work. All right, on number 4, I'm going to move faster than I have up to this point, because at this point, you really should be starting to pay attention. This video is going to run way too long as it is, but it had to be said. I feel like it had to be said. Like, how do you do this stuff? So in number 4, I have to solve one of my equations for either x or y, and it doesn't matter which variable you solve for. But the bottom equation looks simpler to work with, so I'll solve the bottom equation for eeny, meeny, miny, mo, catch a tiger by the toe. I'll solve the bottom equation for y. Okay, so that's what I'm doing here, minus 7x, or -7x minus 5y equals 8. All right, so I'm going to add 7x to both sides. Remember, I'm solving for y. And I have negative 5y equals 7x plus 8. And now I'll go and divide each term by negative 5. Cancel those negative 5s out. And I have y equals, and here I'll pull that fraction out in front, negative 7/5 x minus 8/5. This is a bit of a nightmare. This is scary because we have fractions, and no one likes to work with fractions. Okay, so that's what y equals. So that's what I'm going to plug in to the other equation. Okay, you can do this, all right? You can do this. If you want to know what you're looking for, you can go to Desmos just to ease your anxiety about working with the fractions, and you can type in negative 21x minus 15y equals negative 6, and negative 7x minus 5y equals 8. Okay, they're parallel lines, so there's no solution. Okay, so that's what we're headed for. Well, let's see that play out in real time. I'm going to run out of scratch paper here. So I'll transfer my equation over. I did the bottom equation and I solved for y, so I'm going to plug negative 7/5 x minus 8/5 into the top equation. Okay, this is number 4. So I'll write negative 21x minus 15. And instead of writing y, I'm going to put a huge open parentheses and stick in negative 7/5 x minus 8/5. Negative 7/5, negative 7/5 x minus 8/5. All right, and then that equals negative 6. Okay, so now we have negative 21x, and we have to multiply negative 15 times negative 7/5 x, negative 7/5 x, and negative 15 times negative 8/5. Okay, because we're going to distribute multiply here. So I'm going to do this in pieces. I have negative 15 times negative 7 over 5 x, and I have negative 15 times negative 8 over 5, and that equals negative 6. All right, so this negative 21x just keeps coming along. Nothing happened to it. And now we have to do negative 15 times negative 7. Well, we know it's going to be positive. Before you start multiplying 15 times 7, I want you to recognize something important. Right? So people freak out about these fractions, but they're really an opportunity to do something cool. Take a look at 15. 15 is 3 times 5. Okay, so instead of writing negative 15, What if I wrote negative 3 times 5 and then wrote times negative 7, and I put all of that over 5? Then x, all right? Just focus on that part right there. You can bring down the rest of this. Minus 15 times negative 8 over 5. Set all that equal to negative 6. The benefit of writing it out like this as the product of the factors is that I can cancel these 5s. And it dramatically simplifies the situation. In fact, I can do the same thing there with this negative 15. Right? I could go in there and write negative 3 times 5. Because that's negative 15. Negative 3 times 5 is negative 15. And I can cancel those 5s out. All right. So now I rewrite negative 21x. And then I do negative 3 times negative 7. Well, we know what 3 times 7 is. That's 21. So negative 3 times negative 7 is 21, because a negative times a negative is a positive. So we put plus 21x. Look what happened here. Now I have negative 21x plus 21x. Those two things are going to cancel out. And now all I have to do is negative 3 times negative 8. Well, what's negative 3 times negative 8? Negative by negative is a positive. 3 times 8 is 24. So that's plus 24, okay, equals negative 6. On the left side, when we try to combine these like terms, they cancel each other out. Negative 21x plus 21x is 0. So all I'm left with is 24 equals negative 6. Now the question is this true? So this isn't the brakes have hit, right? You're screeching to a halt because you thought you were going to get x equals something. But we already know the lines don't cross. And this is how you would know the lines don't cross when you're doing it with the math. You have some number equal to a completely different number. This is not true. Okay? No, this is not true. 24 does not equal negative 6. And that's how we know there is no solution. And remember what no solution tells us. You can only have no solution when you have parallel lines. All right? And what do parallel lines tell you? Parallel lines tell you that you have the same slope and different y-intercepts. So these are all the things that we know based on that information. Let's go back and check and see if all that stuff is true. All right, we've got parallel lines, so the same slope, right? Do they have different y-intercepts? Well, this purple equation has one at 0.4, and this black equation has one at negative 1.6. So, yep, parallel lines, same slope, different y-intercepts. No solution. They never cross. Doesn't matter how far you zoom out, they never cross. So, that's how we got to the answer for number 4. Number 4 is no solution. Okay, and now we're on to number 5. Solve each system by elimination. Okay. We always think of this as the simpler of the two things, substitution and elimination. Let's start by stacking all of our, we have to rewrite. So 4x plus 5y equals negative 3. And negative 4x minus 3y equals 5. Okay? Do we have common coefficients? Okay, yes we do. 4 and 4. So we can just draw our line. We don't have to multiply either equation by any term. We can just draw our line. And how should we eliminate? Should we eliminate using addition or subtraction? Well, we should eliminate using addition, right? 4x plus negative 4x is 0. So using addition, we get this to be 0, so we've eliminated the x, and 5y plus negative 3y is 2y, and negative 3 plus 5, so you're basically subtracting 3 from 5, that's 2. All right, so now we have to do that final step and divide both sides by whatever's in front of the y. So we divide both sides by 2. These 2's cancel, and you have y is equal to 2 over 2. All right, well 2 over 2 reduces down to just 1. So you found that y equals 1. And now you just plug this back into either of your two equations. The top one has fewer negative signs, so we'll use the top one. We've got 4x plus 5, open parentheses, insert that 1 instead of the y, and set that equal to negative 3. Okay? So now I've got 4x plus 5 times 1, which is just 5, plus 5 equals negative 3. Keep peeling the apple. Subtract 5 from both sides. And now you've got 4x equals negative 3 minus 5, which is negative 8, because it's like 3 plus 5, but with a negative sign. And now we divide both sides by 4. X equals negative 8 divided by 4. Negative 8 divided by 4 is negative 2. So x equals negative 2. We found that y equals 1 and x equals negative 2. So our solution is x comma y. Negative 2 comma 1. All right? And look, that's an answer choice, but we can actually do better than that. We can check it in Desmos. Let's go put in 4x plus 5y equals negative 3. And negative 4x minus 3y equals 5. Where do they cross? At negative 2 comma 1. They cross at negative 2 comma 1. So now let's go back to the problem. And we finally feel super comfortable by circling C. Okay? Well, now let's do number 6. I want to point something out right away. When I write this, negative 3x plus 2y equals 5. And then I write negative 3x plus 2y equals 5. I notice that I've written the same equation down 2 times. All right? If you solve this system, you would need to try by using subtraction. because negative 3y minus negative 3y cancels out, or I said negative 3y, negative 3x minus negative 3x, the minus minus becomes a plus, and these cancel out. Now 2y minus 2y cancels out. All right, so I have 0 plus 0 equals 5 minus 5, which is 0. So I have 0 equals 0. Now here's a question. Is this true? Well, yes, it's true. 0 equals 0. Yes. So when your question about whether it's true or false is yes, then you know that you've got a situation with infinite solutions. You've got the same line, same slope, same y-intercept. Okay? All these things can be deduced just from seeing that 0 equals 0 or 4 equals 4 or 10 equals 10, whatever it is that you get. If it's true, right, then you know all those things. So in number 6, you have an infinite number of solutions. You can go check in Desmos. Type negative 3x plus 2y equals 5, and that's the green line. Now watch this, negative 3x plus 2y equals 5. See, when I type that 5, it just maps right over the green with the purple. So that's how I know that they're infinite solutions. That's number 6. Okay, now in number 7, we have a situation here where we need to multiply one of these two equations by some variable to make it equal to the other equation. All right, because none of my x's or y's add up. They're not the same. I don't have common coefficients. I have a 3x and a 2x and a negative 9y and a negative 2y. Those are not common coefficients. So in order to make them common, I have to do something to one of the equations or maybe both of the equations. In this case, I have to do something to both of the equations. Let's say that I want to eliminate the x variable. I have to multiply the top equation by 2 and the bottom equation by 3, because 2 times 3 is 6 and 3 times 2 is 6. But when I do that, I have to multiply that 2 through the entire top equation and this 3 through the entire bottom equation. All right, so let's do that and then rewrite our answer. 2 times 3x is 6x. 2 times negative 9y is negative 18y. 2 times 6 is 12, so this equals 12. Well, now I can subtract. What am I going to solve for here? Oh, I was just about to do substitution. Now I do the second line. 3 times 2x is 6x. 3 times negative 2y is negative 6y. 3 times 8 is 24. All right, so now I have common coefficients. I can draw my line. And I have to decide addition or subtraction. All right, well, it's going to be subtraction. 6x minus 6x is 0. So I've eliminated the x. Now I have negative 18y minus negative 6y. So I've got a negative and a negative. It's a positive. I have to do negative 18 plus 6. Well, that's negative 12. So negative 12y equals 12 minus 24 is negative 12. Well, that went from complicated to easy very quickly, didn't it? Because now if we just divide both sides by negative 12, we get y by itself, and y is equal to negative 12 divided by negative 12, which is positive 1. Okay, so now I just have to plug that 1 back into either of my equations, and I'll just choose the bottom one. Whoops. We write 2x minus 2 times 1, because we're going to take this 1 and plug it in for the y, equals 8. So I have 2x minus 2 equals 8. I add 2 on both sides, and I have 2x equals 8 plus 2, which is 10. And then I divide both sides by 2. Those 2's cancel on the left, and I have x equals 10 divided by 2, which is 5. So now I have x equals 5 and y equals 1. So the solution to my system, x comma y, is 5 comma 1. All right, let's see if that links up with what we find in Desmos. Three x minus 9y equals 6, and 2x minus 2y equals 8. Where do they cross? What are we hoping for? We're hoping for 5 comma 1. There it is. They cross at 5 comma 1. So we know we did it right. Okay, now on to number 8. Number 8 is going to require some scratch paper because the form of my equation isn't equivalent. I have negative 10y plus 28 equals 16x, and then I've got 9y equals negative 9x plus 9. So one thing we could do is simply subtract 28 from both sides of the top equation, and then we'd have at least an equivalent form. So let me show you what I mean. I've got here negative 10y plus 28 equals 16x. And then what I'm going to do is just subtract 28 from both sides. And I have negative 10y equals 16x minus 28. Okay? And so what I'm going to do now is write my other equation beneath it, which is 9y equals negative 9x plus 9. Are we ready to draw our line, or do we need to do anything else? Well, I need to do something else because I don't have any equivalent coefficients. So what we could do is we could multiply the top equation by 9 and the bottom equation by 10. And that would turn these two numbers into 90s. This would be negative 90, this would be positive 90. And we could eliminate the y variable by addition. So let's do that. 9 times negative 10y is negative 90y. We set that equal to 9 times 16x. I have no idea what 16 times 9 is. but I will in a moment. 9 times 6 is 54. 9 times 1 is 9, plus 5 is 14. So 16 times 9 is 144. So negative 90y equals 144x. And now I have to multiply 9 times negative 28. So I'll just put the minus sign and then do 28 times 9. 28 times 9. 8 times 9 is 72. And 2 times 9 is 18 plus 7. 18 plus 7 is 25, so this is 252. All right, now on the bottom, I've got 10 times 9y, that's 90y, equals 10 times negative 9x. All right, that's negative 90x. And 10 times 9, that's plus 90. Make sure to line up all these terms. And now you're ready to solve this system using elimination by addition. So negative 90y plus 90y is 0. So these cancel. And you have 0 equals 144x plus negative 90x. Well, that's the same thing as subtraction. So we'll just do 4 minus 0 is 4. And then I can't take 9 from 4, so I'll borrow here and put a 14 here. 9 from 14 is 5. Right? This is a 0. So 0 equals 54x. And now I have to do negative 252 plus 90. So I know that the bigger number is negative, so it's going to be negative. And I just do subtraction again. 2 minus 0 is 2. And I have to borrow from the 2 and make this a 15. 15 minus 9 is 6. Then I bring down the 1. Okay? So now I'm going to get x by itself on the right side by adding 162 to both sides. And on the left side, 0 plus 162 is 162. And this equals 54x. And on the right side, this cancels. So now I just have to divide both sides by 54. Now you might be looking at that and saying, oh, that looks really hard. I don't know what 162 divided by 54 is, but you can prime factor 162 relatively easily. Okay, so I'll divide by 2 because I know it's even. 2 goes into 16 8 times with no remainder. 2 goes into 2 1 time. So 2 times 81 is 162. Break this down. You've got 3. 3 goes into 8. 2 times with 2 as a remainder. And 3 goes into 21 7 times. Break down 27 into 3 times 9. And break down 9 into 3 times 3. That's called prime factoring. Now we'll do the same thing with 54. All right, this is how we would do this without a calculator. First, I would do 2. That's the smallest prime factor that'll go into an even number. 2 goes into 5 2 times with 1 remainder. And 2 goes into 14 7 times with no remainder. Then break this down. That's 3 times 9. And that's 3 times 3. Let me show you what you can do here. Circle all the numbers that are in common with both factor trees. This one and this one. So these 2's are in common. I've got a pair of 3's that I can circle. Another pair of 3's that I can circle. And a final pair of 3's that I can circle. Now cross out everything you circled, and the only thing that's left is the answer. Okay, you just canceled everything out except this 3 right here. Okay, which means that 162 divided by 54 equals 3. That's pretty cool. So x equals 3. Well, x equals 3. And so I just plug that back into one of my original equations. Let's find out what y is. So one of my original equations said 9y equals negative 9, open parentheses, put the 3, close parentheses, plus 9. So I have 9y equals negative 9 times 3 is negative 27, plus 9. Oops, you couldn't see anything I was writing. This is what I wrote. So I have 9y equals negative 27 plus 9 is negative 18. And now I divide both sides by 9. And y equals negative 18 divided by 9, which is negative 2. So I have x equals 3 and y equals negative 2. All right, there's the process that we went through to get that. So our solution would be x comma y, which would be 3 comma negative 2. So we can go check that answer in Desmos. We do negative 10y plus 28 equals 16x, and 9y equals negative 9x plus 9. Well, what did I do wrong? Hang on, I think I typed something wrong. Negative 10y, oh, I put plus 29. There, should have been plus 28. Let's see where they cross. 3 comma negative 2, right? Let's go see if that's what we found. Here it is. We found that it crosses at 3 comma negative 2. So the solution to the system is B, 3 comma negative 2. Okay, the good news is we're done with solving systems, but these final two questions require us to use the point slope formula. This is very fast. You just have to identify that this is a parallel line here in number 9, and parallel line means same slope. Okay, so if you can identify the slope, then you can use the point slope formula to plug it in. All right, first let's label these points x1 and y1. Well, the slope in this equation right here is 6 over 5. All right, so we want to write an equation with the same slope passing through this point. So you have a slope and you have a point, 0 comma negative 4. x1, y1. So you're going to use the point slope formula. Y minus y1 equals m, open parentheses, x minus x1, close parentheses. So we just replace y1 and x1 with what we identified them to be, and we replace the m with the slope. Y minus negative 4, a double negative there, equals m, which is 6/5, open parentheses, x minus x1, which is 0. Let's simplify this equation. Negative negative is a positive, so I have y plus 4 equals, and then I will distribute multiply here, and I don't even need to do the second distribution because it's 0. 6/5 times negative 0 is 0. I just have 6/5 times x, 6/5 x. So my final step is to subtract 4 from both sides. These cancel out on the left, and I have y equals 6 over 5x minus 4. Y equals 6/5 x minus 4. Right here. Okay, that's the answer. And there's the work. Okay, and finally we'll do number 10 here. Number 10 asks us to find the equation of a line passing through this point, 1, 4, which I've labeled x1, y1, and perp, okay, perp means perpendicular to this equation. All right, so perp means negative reciprocal slope. All right, so you just have to remember that. A negative reciprocal slope. So what is our original slope? Okay, m equals negative 1 over 6. Well, if m equals negative 1 over 6, then the negative reciprocal slope, which I write m to the negative 1 power like this, the negative reciprocal slope is going to be equal to, what we're going to do is flip the fraction. So we'll write 6 over 1, that's the reciprocal, and bring this negative sign. That's just the reciprocal. And now we put a negative sign in front of that negative sign, all right, which makes it a positive. So the negative reciprocal of negative 1 over 6 is 6. Well, now I just want to find the equation of a line passing through with a slope of 6. I want to find the equation of a line with a slope of 6 and these coordinates, passing through these coordinates 1, 4, which we identified as x1 and y1. I use the point slope formula. Y minus y1 equals m x minus x1. And I just plug in my numbers. Y minus 4 is equal to not m, but 6, open parentheses, x minus x1, which is 1, close parentheses. Okay, so now I just distribute this 6. I'll rewrite y minus 4 on the left side and set that equal to 6 times x, which is 6x, and 6 times negative 1 is negative 6. And then I add 4 to both sides. Right? Cancel these out. Y is equal to 6x, and then negative 6 plus 4 is negative 2. 6x minus 2. Right there. Y equals 6x minus 2. That's B. All right. So if you want to look at the bonus questions now, you can factor these numbers. All right. So I'll show you how to prime factor and simplify these radical signs. So if I've got the square root of 50k squared, I want to simplify that number. So the first thing I have to do is prime factor 50. Well, that's 2 times 25. And 25 is 5 times 5. What I'm looking for here is a pair of 5s. That's what I was hoping to find. Now k squared is k times k. So watch how I'm going to write this thing. I'm going to rewrite the square root of 50k squared as the product of all the prime numbers. 2 times 5 times 5. Okay, that's 50. Times k times k. Whenever I see a pair of these numbers like this, or a pair of letters, I can pull them out of the square root. And I just write one of them. So I'll write 5 and k, and that effectively cancels those out of the square root. So now I have 5k square root 2. And that's how I got c. The square root of 256p squared, right? Well, you would need to prime factor 256. So we'd start with 2. 2 goes into 2 once with no remainder. 2 goes into 5 two times with 1 remainder. And 2 goes into 16 8 times with no remainder. So 2 times 128 equals 256. And now we'll do the same thing again. I'm really dividing these numbers by 2, but I'm doing it in my head. So 2 goes into 12 6 times with no remainder, and 2 goes into 8 4 times with no remainder. All right, well now I'm getting to where I can just do it. 2 times 32, 2 times 16, 2 times 8, 2 times 4, 2 times 2. Wow, that's a lot of 2's, isn't it? So this is 1, 2, 3, 4, 5, 6, 7, 8 2's. So let's go back up here and remember that p squared is p times p. Let's go back up here and write the square root of, and put a huge square root symbol, and put 1, 2, 3, 4, 5, 6, 7, 8 2's. 2 times 2 times 2 times 2, that's 4 of them, times 2 times 2 times 2 times 2, that's 8 of them, times p times p. And now I can group them by doubles like this. Watch this now. So each one of these gets to come out. Everything I've circled gets to come out. So I cancel that and put a 2. Cancel that and put a 2. These are separated by multiplication. Cancel that and put a 2. Cancel that and put a 2. And cancel that and put a p. So now we just need to do 2 times 2 times 2 times 2 to fully simplify it. I totally got rid of the radical sign. There's no more square root. So now I do 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So this equals 16p. So it's D. The square root of 256p squared reduces down or simplifies to 16p. All right, here's the bonus that we talked about in class. The astronomy stuff that we were talking about. How many stars are there in the Pleiades, the so-called seven sisters by the ancient Greeks? Star cluster asterism. Did you know the Japanese word for the Pleiades is Subaru, just like the car? Well, there are 7 stars in that star cluster. There's a lot more, but we only see 7, and we only recognize 7 in the mythology. Okay, number 14, which of the following stars is in the constellation Orion? Well, these are all stars, but only one of them is in the constellation Orion, Bellatrix. Number 15, what did the ancient Egyptians call the constellation Orion? They called it Osiris. These are also other gods and goddesses from ancient Egyptian mythology, but Osiris was the one that the Greeks called Orion. What is the name of the brightest star in Canis Major, also called the dog star? Well, the dog star is Sirius, okay? And just so you know, the ancient Egyptians called this Isis. The Greeks called it Venus. Just a little side note there. So we have gone through this entire test review. You know, this is one of those comprehensive 6 weeks exam reviews, so it makes sense that it took some time. It makes sense for sure. There was a lot of work involved. But I feel like we learned something. All right, so thank you very much for your attention. And if this video was helpful to you, please consider giving it a like or a thumbs up. And if you have not already, please leave a comment and subscribe to the channel and hit that notification bell so you're always alerted to new videos on this channel. Thanks.